Welcome to part 7, summary of what we have learned till now. So first part is more about wrapping up on the key concepts that we have learned. So let's go over the summary of each and everything that we learned till now. The first thing is tensors. Tensors are the fundamental data structures in TensorFlow, representing multidimensional arrays of numerical values. Scalars are zero-dimensional tensors, vectors are one-dimensional tensors, matrices are two-dimensional tensors, and higher dimensional tensors are arrays with more than 2 dimensions. Tensors can be constants, which are immutable, variables, which are mutable, or placeholders for input data during computation. The next concept was computational graph. TensorFlow uses a computational graph to represent mathematical operations as nodes and data flow as edges. Nodes in the graph represent operations such as addition, multiplication, and neural network layers. Edges represent the flow of tensors between operations, including the input-output relationships. The next concept, sessions. TensorFlow uses sessions to execute operations and evaluate tensors within a computational graph. Sessions allocate resources such as CPU or GPU and manage the execution of operations in the graph. Sessions are responsible for initializing variables, running operations, and releasing resources after computation. Next concept, variables and operations. Variables are mutable tensors that hold values that can be updated during computation. Operations are functions that take tensors as input, perform computations, and produce output tensors. TensorFlow provides a wide range of built-in operations for mathematical operations, neural network layers, optimization algorithms, etc. Next one, neural networks. Neural networks are computational models inspired by the structure and function of the human brain. TensorFlow enables the construction and training of neural networks for tasks such as classification, regression, and clustering. Common neural network architectures include feed-forward networks, convolutional neural networks, which are CNNs, recurrent neural networks, RNNs, and transformers. Next concept, training and optimization. Training involves iteratively adjusting the parameters of a model to minimize a loss function, using techniques such as gradient descent and backpropagation. TensorFlow provides optimizers, loss functions, and metrics for training and evaluating machine learning models. Hyperparameter tuning, regularization, and early stopping are common techniques used to improve model performance and prevent overfitting. Next concept, deployment and serving. Once trained, TensorFlow models can be deployed for inference on various platforms, including servers, mobile devices, and the cloud. TensorFlow Serving is a system for serving machine learning models in production environments, providing scalable and efficient inference capabilities. TensorFlow Lite enables the deployment of models on mobile and embedded devices with limited computational resources. Next concept is TensorFlow Extended, or TFX. TFX is a platform for building end-to-end machine learning pipelines from data ingestion to model deployment and monitoring. TFX components include data validation, pre-processing, model training, evaluation, and serving, facilitating the development and deployment of production-grade ML systems. Next concept is TensorFlow Quantum, or TFQ. TFQ is an open source library for quantum machine learning, allowing researchers and developers to build and train quantum machine learning models using TensorFlow. TFQ integrates quantum computing concepts and tools with TensorFlow's computational graph and optimization capabilities, enabling the development of quantum-enhanced machine learning algorithms. So just to summarize, TensorFlow is a powerful framework for building and training machine learning models, providing a wide range of tools, libraries, and functionalities for developing and deploying production-grade ML systems. Understanding key concepts such as tensors, computational graphs, neural networks, training, optimization, deployment, and specialization extensions like TFX and TFQ is essential for effectively using TensorFlow to solve real-world machine learning problems.